physicists. The path that's radical is to say, what if we extend that ambiguity resolution from the state of the universe, that is the states of all the particles and fields and so on, where it's accepted that that is part of normal quantum mechanics, what if we extend that to the laws that underpin them? So instead of taking fixed Platonic laws and fuzzy states that can be resolved through observations, supposing the laws themselves are fuzzy for the reasons I've outlined here, then we see how observers connect to the laws in this deeper quasi-mechanistic manner. Now, this is what John Wheeler would call not an idea so much as an idea for an idea. It's the outline of a research program, but it's one that I think could provide this linkage between space, time, laws, life, and observers without appealing to anything outside the universe as God-given or imposed upon it from outside. So that's all I have to say. I think it's progress of a sort, but it's work in progress. Thank you.
Perhaps just one or two very quick questions, because I actually want to... Terry.
So I remember...
you know the rules.
Terry Sainovsky. I had the privilege of working with John Wheeler over 30 years ago, and I remember him saying way back then, "It from bit."
Right.
And he likes these little slogans. It from bit.
From bit.
It from bit. That the universe, particles come out of piece of information, a program, as you say, running on a computer. But it seems to me that just replaces the turtle with the computer.
Well, I showed the sort of turtle loop, and I think you're quite right. If all you want to do is to make information primary and matter then come from it. If I'd had a longer talk, I would have showed a slide of precisely that. You know, in the conventional way, you've got mathematics at the bottom, laws of physics, then you've got matter, then you've got information, then you've got understanding, you know, in a sort of great chain of being. And just flipping over the bottom ones doesn't really get you there. What you need to do is to, and in fact, well, it was up there, it's a self-synthesizing loop where each of these things supports the other. I showed the turtle loop briefly. So that's what I'm after. Now, of course, people still say, well, that doesn't, you know, it's still not an ultimate explanation for existence, because even if everything explains everything else in this loopy manner, you could still say, well, why that particular loop? Why does that exist rather than some other self-consistent loop? Well, it could be that all self-consistent loops are out there somewhere, and this is just one of them. But I think that's better than just sort of having the Tower of Turtles and a levitating super turtle and just declaring that's it. Because we will never, ever resolve these issues about I prefer a transcendent God, I prefer mind at the bottom, I prefer mathematics at the bottom, I prefer superstring Lagrangian. How are we ever going to resolve that?
Paul Churchland, Professor Davies. There is a possibility within the neighborhood of possibilities you've scouted in your talk that you didn't mention, and I'd like your comment on it. Let me start with an analogy. Young children often think that there's only a finite number of numbers and there is a biggest number, and they're rather shocked to learn that there isn't one. Right. And one might say the same thing about the sequence of theories that intellectual communities produce over time. Our theories get deeper and more accurate and more penetrating, and each explains to some degree the success of its precursor and so forth. And so here we're looking at a stack of theories, and there is a possibility that the question, how do we explain the fundamental theory, supposing there is one? That question could be answered, well, you're assuming that there is one. Perhaps theories just get more and more and more successful.
It's turtles all the way down.
Ad infinitum. But the turtles change. The turtles change. They're not identical turtles. And I'm here suggesting that theories are, after all, creations of cognitive creatures made in an attempt to understand the universe around them. And if the universe is, as it may be, infinitely complex, and any machine inside it will be finitely complex, then any such creature, such as ourselves, are doomed to have at most a partial understanding of what's going on. Right. And that will endure forever, even though we'll get a better and better and better grasp.
Yes, I hope you're wrong. And of course, it is often said that all we're doing is just making successive approximations to, you know, the truth or something that's out there. or just building better and better models of reality. Again, you know, Stephen Hawking did one of his famous U-turns on this very issue, because if one appeals to Gödel's incompleteness theorem, there's a very deep sense in which you can never know that you've got the last word on the subject. Now, some people like Freeman Dyson draw inspiration from that. There'll always be mystery. See, some people like the mystery. I've never liked that. That's just purely a personal thing. I like to feel, yes, we can grasp this if we only put enough effort into it. You know, I'm motivated by the thought that there is an answer out there, and that using scientific methods of inquiry, we can maybe get to what it is. But I have to concede that it may just be a mirage. Maybe we're just chasing after something that simply doesn't exist. Or maybe, and the point, the last paragraph of the book, I make the point that, and it was implicit in what you said, that our minds have evolved to solve certain problems. And we set up problems. The conceptual framework we use to discuss these sorts of things at this meeting, in terms of cause and effect, and you know, gods and laws and mathematics and scientific method and so on, all of these things we've inherited from evolutionary happenstance. And it could be that now we can transcend these human limitations through artificial intelligence and building machines that can engage in intellectual inquiry that would be completely beyond us. And these would not be restricted by biological evolution to certain patterns of thought. Maybe they'll crack the problem, but maybe it would be completely incomprehensible to us because we simply can't put it into the language, into the conceptual framework that we've inherited from biology.
Yeah, just one more before we move on. Lawrence Krauss.
Two comments, Paul. One, just to put in perspective, I'm not sure that Stephen Hawking's picture of being able to limit what you can say about the past based on your observation of the present is really accepted as broadly as you might suggest. I think there are people who have big problems with that still. But
you mean other people have problems with Stephen's
interpretation of that?
I think that's right. Yeah.
But on the question you gave, and it's again, it's a little technical, so I won't waste a lot of time here. But as you know, I've thought a lot about computing in the future, and this 122 bits worries me a little bit because it's kind of observer dependent. It's the computational power of a universe within the context of any given observer, right. And the question to me of whether the universe is limited by a single observer or it seems to me questionable first, and secondly, the question of 400 entangled particles. Whether I think the question of whether that's going to use up all the bits in the universe, it depends upon. It can compute without, as long as it doesn't process that many bits. I don't see any problem.
Right. If you're a Platonist, it doesn't matter because it's computing in this Platonic heaven, and it doesn't.
Well, no, but I mean, it doesn't. The quantum evolution, I think, can be completely unitary as long as it doesn't process bits. But the more important question is the fact that I think this limitation of the universe based on an observer is something I would worry about.
You don't like that, right?
Yeah.
Right. Well, and of course, it'll appear mysterious to many people here as to why it's finite, and it has to do with the finite speed of light and age of the universe and so on. And so it does get.
But the actual universe itself is far bigger than the horizon of an individual observer.
Yeah.
So therefore, it's not
absolutely.
as limited.
So it's causally disconnected patches.
Yeah.
So you have to buy that is fundamentally significant. And that really is a matter of judgment as to whether you think something like the holographic principle, as say Lenny Susskind would, it really gets to the heart of what nature is about, or whether it's a sort of little technical extra.